All right, so chapter 9, guys, transformations. This is a change in the position, shape, or size of a figure. The original figure in a transformation is what we call the preimage. So that's the figure that we'll start with, and whatever we do, or the resulting figure would be called just the image. All right? So, let's talk about our first transformation. This is what we call a translation. A translation is where you slide the figure. You can slide it up, down, left, or right, or you can do a combination of two of those things. So an example, you could go up and right, or down and right, or up and left, or down and left. So something like that, all right? So, for the first one here, it talks about the preimage being D, E, F, G. The image is D apostrophe, E apostrophe, F apostrophe, and G apostrophe. So whenever you see that apostrophe, that's the new image, right? So that we want to figure out how it's translated. To do that, we just pick any point that we want to use from the original pre-image and figure out how it moved to get to the image. So let's use D for this one. We're going to go to the left 1, 2, 3, 4, and 5. If we go to the left, the x value is a negative 5 because we're going to the left, right? So it's kind of like counting slope. Then we go down 1, 2, and 3, which means our y is going to be like a negative 3. So when we said how is this figure translated at the bottom here, we're going to take x and we're going to subtract 5 from it. And then we're going to take the y and we're going to subtract 3 from it. And that's how we would write it for a translation like that, all right? So let's do this one here. Let's start with any point we want to start with. I like to start with the one closest to the new image. So I'm going to do S, which means I have to get all the way down to this S. To do that, we go to the right 1, 2, 3, 4, 5, 6, 7, and 8. So it's a positive 8 for the X. But then we go down 1, 2, 3, 4, and 5. So it's a negative 5. So when we write that, we write it as an ordered pair. We're going to say X plus 8 because it was a positive 8. And then we're going to say Y minus 5. And that tells us that the y goes to the right, or the x goes to the right 8, the y goes down 5, right? So let's do the same thing here, but now we're going to draw the resulting image. So they've given us that x, y, and then the transformation for this says we're going to go x plus 3 and y plus 2. Well, if it says x plus 3, we're going to go to the right 3. And then if it says y plus 2, we're going to go up 2. So what we need to do is for every point in this figure, we need to do the same thing. So we're going to go to the right 3 and then up 2. So if I start with this point, we're going to go to the right 1, 2, 3, and then up 1, 2, puts my point right here. All right. Now we got to do the same thing with this point. So we're going to go to the right 1, 2, 3, and then up 1, 2, which would put it right there. And then we need to do the same thing with this third point here. We go to the right 1, 2, 3, up 2. Puts it right there. So if we draw our resulting image, it would look just like that. All right? So go ahead and pause it here. I want you guys to try this one. Once you're done, go ahead and hit play, and then we'll see what it looks like. Okay, so now that you've had a chance to try this one, guys, let's go ahead and figure out what it says we're going to do. So for the x plus 5, that says we're going to go to the right 5. And then the y minus 3 says we're going to go down 3. So for every point, we're going to follow that. So let's start with this point at the top. We're going to go to the right 1, 2, 3, 4, and 5, and then down 1, 2, and 3, which would put it right here. All right? Now we're going to do that for every other point in it as well. So let's start with this, or second one we'll use is this one. 1, 2, 3, 4, 5, 1, 2, and 3. Then the bottom one, 1, 2, 3, 4, 5, 1, 2, and 3. And then for our last one, 1, 2, 3, 4, 5, 1, 2, and 3. If we draw our image, it should look like the same exact image, just slid to the right and down. All right? All right, the next one we're going to talk about is a reflection, guys. A reflection is where you flip a figure across the line. So think of it as a mirror. When you look into a mirror, you get a reflection. It's not the exact same. It's actually the mirrored image of it. It's a flipped image, right? So it says A has been reflected over the y-axis. The easiest way to remember this, guys, is that if it reflects across the y-axis, then the x changes. All right? Which means if the x is positive, it becomes negative. If it's negative, it becomes positive. So when you look at this, it says negative 2, 3. If we're flipping across the y-axis, the x changes, so that negative 2 becomes a positive 2, and the y stays the same. We don't do anything with that. You can look at it at the image above here. So A is here. If we reflect across this y equals line right here, then it becomes over here. The only thing that's changed is that negative 2 became positive 2, all right? Do the same thing here with B. It says reflect across the x-axis, though. When we reflect across the x-axis, then the y changes, all right? Which means, in this one, if we have 1, 1, the y is going to change signs, which means the x is still 1, but the y is now negative 1. And again, you could do that with this figure right here. We have B starting at 1, 1. If we reflect across the x-axis here, it moves below that, which would give you a 1, negative 1. So the y is the only thing that changed, all right? So go ahead and pause it here and go ahead and try C on your own. It says to reflect it across the x-axis. Go ahead and do that now. Okay, so you should have gotten negative 3 and 3 because it's reflected across the x-axis, the y is the only thing that will change, all right? Okay, for our next set of problems, guys, they're going to ask you to reflect across the y equals x. One easy thing to remember for this is if y equals x, then x must equal y, which means we can take the two things and just flip them around, right? So for the first one here, it says A is reflected across the line y equals x. 2, 4 becomes what? Well, if y equals x, then we know that x equals y, so we just switch that order around, and we would get 4, 2. That's all you have to do. So when you think about the line y equals x, guys, it's this line right here. It passes through the origin and has a slope of 1. So just making sure that you remember that if you reflect across it, this a right here moves over here. It's easier just to remember to switch those around, okay? So let's do B together now. B is at 1, negative 3, right? So if we're starting at 1, negative 3, and we want to reflect that across the y equals x axis, we take that and we flip the order around, and we would get negative 3, 1. All right? Go ahead and pause it here, and you guys go ahead and try C and see if you can get the right answer. All right, so at the bottom now you see the answer, guys. You should have gotten that the original C, the pre-image, was negative 1, 2. Therefore, the new image, when you reflect across that y equals x, is going to be that 2, negative 1, all right? All right, so let's reflect this across the y-axis. The first thing is, guys, you got to identify where the y-axis is. It's this vertical line here where x equals 0. So we're reflecting across that. So whenever we're reflecting across that, it's just easier to count. So how far is B away from that? Well, it's 3 spots away, right? So when I do B over here, it's got to be in the exact same spot on the other side. So that's our new B, right? Do the same thing with A. Well, it goes 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, and 7. That would be our new A, right? And then we also have to do C. We go to left 1, 2, 3, 4, 5, which means we have to go to the right 1, 2, 3, 4, and 5. And that's our new C. And if we draw it, it should be the same exact image, just reflected. You'll notice that the B's have to be closer to each other in this because of the reflection. If it wasn't written that way, it would have been a slide or a translation, all right? Go ahead and try to reflect this one across the y equals x axis. Remember, find all your points, and then when you reflect it, if y equals x, then x equals y. So the first thing you want to do is make sure you identify points A, B, and C. Once you've done that, remember, if you're reflecting across y equals x, then x equals y. So we just switch the order around, and we would get 2, 5 for A. For B, we would have gotten 8, 2. And then C, we switch 0, 0 around, and we still get 0, 0. So once we go to graph that, 2, 5 would go right 2 and up 1, 2, 3, 4, and 5, which would put A right there. B, we go to the right 8, 1, 2, 3, 4, 5, 6, 7, 8, and up 2, which would put B right here. And then C is still at 0, 0. So if you graph it, it should look something like that. Now, the question is when we reflect stuff, you don't usually see it overlap. But here's the question that's always asked is, what does the graph look like? Well, if you're doing y equals x, the line would be that. Did we reflect across that line? Yeah, that's the ultimate goal. So A, which was here, now becomes here. B, which was here, becomes here. And C doesn't really reflect across it because it was on that line, okay? All right. The last one we're going to talk about is a rotation. A rotation is a transformation that turns every point of a preimage through a specified angle and direction about a fixed point. The fixed point is what we call the center of rotation, all right? So imagine taking an image and just rotating it either clockwise or counterclockwise, all right? This example shows a 60 degree, but in geometry, we're not actually going to deal with 60 degrees much. We're going to deal with three main ones. We're going to deal with a 90 degree, a 180 degree, and a 270 degree. Those are the three main ones we're going to deal with. So if you look here, the original image shows a T, correct? When you do a 90 degree rotation, it switches to the other part of the graph, but it also turns the image on its side over here. So now the T looks like this. Then we go to 180, we again move spots on the graph, but then it turns that T upside down. And then the last one, a 270 degree rotation, turns it to another point on there, and then it turns it to facing the left. So that's what you've got to understand with the rotations. You've got to make sure that not only is it moving its spot, but it's also turning the image on its side or around, however it goes, okay? So let's go ahead and do this one together. It says rotate the image 90 degrees and 180 degrees in the space provided. So we're going to start with a 90 degree here, and then we're going to do the 180 degree here, all right? Now, this question should have given you a little bit more information. So what we're going to do is we're actually going to rotate it clockwise, all right? Make sure you know clockwise means as a clock, or the same way that the hands on a clock go. So if I'm rotating this image 90 degrees clockwise, that image right here now should look something like this, where the long end is pointing out to the right and it's moved quadrants, all right? And then if I rotate it another 90 degrees, which makes it 180, then the long end's going to point down like this, and again, it's moved to a different quadrant. So that's a rotation, and we'll work a lot more on that in class to make sure you get it, but make sure you know the three main rotations we're going to deal with are 90, 180, and 270. All right, that's our notes for this section. Make sure you come in with your notes filled out in class.